Hello, everybody. Welcome back. We are discussing factoring today. And so factoring is so extensive, I've decided to break it up into two sections. The first section will include factoring by finding the GCF, and then moving on to factoring by grouping. And then last but not least, we'll talk about factoring the easy trinomials. So for now, guys, we're just looking at factoring out the GCF. GCF stands for the greatest common factor, the greatest common factor. Oops, I think I just erased something, Shazam. Okay, let's go back to that. Okay, I gotta take it off the eraser. And so here, when you're factoring with the GCF, the first thing you have to do is to identify what the GCF is. The GCF could be a single number as in a value. It could be a variable, or it could be a combination of a number and a variable or variables. Now, once you've identified this GCF, you are to then move on to dividing each term of the polynomial, I'm going to try and squeeze all of that in here, of the polynomial. And by the way, I love abbreviating, so I'm just going to be abbreviating too, of the, okay, there we go, there's the writing. Polynomial by the GCF, okay? So now, once you do this, guys, the third step is to write the format. Now, the format is simply this, guys. You have your GCF in front of a set of parentheses. And then inside the parentheses, you have your leftovers after dividing each term of the polynomial by the GCF. That's how you do this, okay? I forgot to put my S here, okay? You put your leftovers there. So when you write your factored form, make sure you have your GCF in front of the parentheses, and then your leftovers go inside the parentheses. So what I'm going to do right now is go and do a few examples with you guys. I think I'm going to try to do 3 examples with you guys right now. So here's example number 1. We're going to keep it very basic. This one is 5x squared minus 15. Now, like I said, I am going to keep it very basic. So let me show you how you go back finding this GCF. So I am going to factor the 15, guys. So you can actually see this, okay, where it's coming from. 15, if I factor it, it factors to 3 times 5. Remember, we're looking for GCF. The C stands for common. What do these 2 terms have in common? What do you see in both terms? That's the question. The factor that appears in both terms is 5, because 5 is divisible by 5 and it's divisible by 15. So 5 goes into 5, it goes into 15. So that's your GCF. Once you identify that, guys, you are to go ahead and write it down, set up your parentheses, and then you are to take each term of the original polynomial divided by 5. But because I did this step right here where I wrote out the factors of each term, once you remove that GCF from the first term, you will notice, guys, automatically you have x squared left over, okay? And then for the second term, once you remove that GCF of 5, you have a minus 3 left over. So guys, this would represent your factored form for this polynomial. Additionally, people, factoring, okay, it's very easy to check. All you have to do is multiply to determine whether or not it goes back to the original polynomial. If it is correctly factored, guys, when you distribute that 5 over parentheses, you should get back to the original polynomial. Remember, factoring involves reverse multiplication, as in you are undistributing the polynomial in this case, okay? So guys, if you can remember that, you can always check your factoring, and it doesn't hurt to check your factoring to see if you get back to the original problem. So that's the first example. Now, let me go ahead and do a secondary example. This one right here, I'm going to have 8a to the 4th power minus 2a to the 3rd power. Oops. Hold on a second. All right, there we go, to the 3rd power, okay? So let's look at the numbers first. I have an 8 and I have a 2. Both 8 and 2 are divisible by 2. So that's part of the GCF. Remember, the GCF could be a number, it could be a variable, or the combination of a number and variable. And then, guys, the first term has a to the fourth, and the second term has a to the third. We can factor out at most a to the third from each term. So 2a to the third would represent our GCF. Now, if you didn't get that, guys, I can write it out for you. If I were to write out the factored form of the first term, it would be 2 times 4 times a times a times a. And if I do it for the second term, it would be 2 times a times a times a. Now, circle what they have in common. They have a 2 in common. Here's one set of a second set is a, and a third set of a. So you see, your GCF is 2a to the third. That's what they have in common. Now, once you identify what they have in common, divide each term by the GCF to figure what's left over. So here, 8a to the fourth divided by 2a to the third will leave you with 4a. Now, additionally, if you go over here, guys, you will notice there's the 4 and there's the a. Now, if you notice with the second term, there's nothing left over. This is why it's a good idea, guys, to do division. Because if you take 2a cubed divided by 2a cubed, what are you left with? 1. Another reason why it's critical to do the division, guys. Because most students will look at this and say, oh, I had 2a cubed and 2a cubed is gone. That means I have nothing, so I don't need a term there. But you started with a binomial. The answer you end up with inside the parentheses also has to be a binomial. So you have to include that -1 in there. If you don't include that -1 in there, guys, it would be considered wrong. So be careful with that, okay? So that's the factored form right there, guys. Now, here comes the third example, and then I'm gonna go ahead and move on. This one is 6x to the fifth, y to the second, minus 8x cubed y to the second. Now on this one, I'm sure you guys can eyeball this and see, oh, both terms have a y squared in common. That's obvious. 6 and 8, they're both divisible by 2. So 2 would be part of the GCF. Additionally, y squared would be part of the GCF. What about the x's though? You got to take out the largest number of x's possible from each term. Remember, it has to be the same number of x's. What's the most number of x's that you can factor out of each term? The largest number of x's you can factor out of each term would be x to the third, and of course the y to the squared. I mean, y to the second power is obvious, so we're just going to go ahead and take that out. Now, you have your GCF 2x cubed y squared. So guys, once again, go to each term and divide each term by the GCF to figure what's left over. Seriously, go to each term, divide each term by the GCF to figure out what's left over. 6 divided by 2 leaves you with 3. These cancel out. X to the fifth divided by x cubed leaves you with x squared. Over here, with the second term, 8 divided by 2 leaves you with 4. And what do you notice with the x's? They cancel out, the y's cancel out, and boom, there is your answer right there. And that was our third example, guys, okay? So I'm gonna leave factoring the GCF alone for now because, guys, we're gonna see it again when it comes to factoring by grouping. So this is part 2 we're moving on to, and that is factoring by grouping. And when you're factoring by grouping, guys, listen, it's another form of finding the GCF, plain and simple as that. Typically, factoring by grouping happens when you typically have 4 or more terms. And the other times you will see factoring by grouping is when you're doing factoring of the hard trinomials, and that's for later on for the second video. But for now, guys, just know when you're factoring by grouping, typically you have 4 or more terms. So here's the steps for factoring by grouping. Number 1, you want to group. That just means to put parentheses, okay? Put the terms in parentheses. The first 2 terms of the polynomial, first 2 terms, and last 2 terms of the polynomial. First 2 terms, last 2 terms. Now, every once in a while, you may have to rewrite the polynomial so you do have terms next to each other that have something in common, but that rarely happens. Typically, you can Group the first two, group the last two. That just means you put parentheses around the first two terms, put parentheses around the last two terms. Step 2, you're going to factor out the GCF, there it is again, from each group. Now, once you factor out the GCF from each group, guys, listen to this, okay? Make sure you're careful with this. The parentheses, what's inside the parentheses must be identical. And if they're not identical, that means that something is wrong, okay? And you need to make sure you go back and check your problem. Unless, of course, it cannot be factored by grouping, okay? So I need to erase all of this so I can move on to the next page. So here we go, guys. Step 3. Now, that parentheses, the reason it's critical for it to be identical, they must be the same, is because it's going to become a GCF. So now you're going to factor out the parentheses, that GCF. Factor it out, guys. Factor out the parentheses. And then write the factored form. And when you write your factored form, guys, the factored form is going to be 2 binomials. 2 binomials. Here, let me write this down for you guys. 2 binomials. It's going to be in the form of 2 binomials, okay, when you write the factored form. So just like with the previous types of factoring, I'm going to do 3 examples, guys. So here we go. Example number 1. I've got a cubed plus 2a squared plus 5a plus 10. So I am going to factor this by grouping. Notice it has 4 terms. I'm going to group the first 2 terms, put parentheses around them. Group the last 2 terms. Notice I'm putting that plus sign right here inside the parentheses, okay? And I like doing that, guys, because just in case there's a minus there, we want to take care of that. So it's better for you to include the sign inside the parentheses, guys, okay? So let's keep going. Now, in the first group, guys, a cubed plus 2a squared, what do they have in common? They both have an a squared in common. So you can factor out an a squared out of each term. By the way, once you become really good with this, guys, you don't have to sit there and divide each term on paper by the GCF. You can do it mentally. So a cubed divided by a squared. If you have a cubed, you take away 2 a's from it, that leaves you with 1a. Same thing here with the second term. If you have 2a squared, you divide it by a squared, that leaves you with 2. And there you go. So guys, we factored out a squared, we're left with a plus 2 inside the parentheses. So the other parentheses, in order for this to work, must also be a plus 2. So now we go to the second group, 5a plus 10. What does 5a and 10 have in common? They have a 5 in common. So we're going to go ahead and factor out the 5. If we have 5a, we factor out 5, that leaves us with a. And if we have 10, we factor out 5 out of 10, that leaves us with 2. That's the same thing as 10 divided by 5, that leaves you with 2. So now what do you notice? Yes, this is identical to this one. So the 2 parentheses are identical, so then that means that you're going to have to factor out the parentheses, which becomes a GCF. So I'm going to factor it out, a plus 2. And if I factor it out from here, guys, what am I left with? A squared. And if I factor it out from here, what am I left with? The positive 5, okay? So the a squared right there, the 5 is right there. So guys, this reflects your answer. There's the factored form. And once again, how do you check it? You just go ahead and multiply, just FOIL it out to see if it gives you back the original problem. All right, guys, so let's do another one. Number 2, I have PQ plus 3P minus Q minus 3. And I am doing this one because of those negatives there, guys. Again, I'm going to group the first 2, group the last 2. So here the GCF is P. I'm going to factor it out. That leaves me with Q plus 3. In the second group, what do you notice? Both terms are negative, guys. So you can factor out a negative 1. If you take a negative Q divided by negative 1, that leaves you with positive Q. Or in other words, what do you multiply Q by to get negative Q? Same thing with the negative 3. That would leave you with a positive 3. And as always, guys, these two parentheses, they must be identical, and they are. So that's going to become a GCF as well. So you factor it out, and that leaves you with P minus 1 for the other parentheses. When you factor it out from here, that leaves you with the P. When you factor it out from here, that leaves you with the negative 1. So guys, here's your factored form for this polynomial. Okay, one more under this section. And so here it comes, number 3. It's AB minus 8B plus 4A minus 32. So on this one right here, guys, again, we're factoring this by grouping. So we're going to group the first two terms, group the last two terms. Notice I'm including the sign inside the parentheses. So in the first group, the GCF, what do they have in common? AB and negative 8B. They have the B in common. So factor it out, and that leaves you with A minus 8. So move on to the second term. You have 4A minus 32. What do they have in common? What are they both divisible by? They're both divisible by 4. So we're going to factor it out, and that leaves us with an A minus 8. So what do you notice? This is identical to this one. So it becomes a GCF. So we factor it out from here, and that leaves us with a B. And if we factor it out from here, that leaves us with 4. And just like that, we have the factored form, A minus 8 times B plus 4, guys. And that's it with factoring by grouping. It's not a very difficult process. Again, it's all about factoring out the GCF. So what I want to do now is go to the third part where I'm factoring the easy trinomials. By the way, guys, there are 2 types of trinomials we're going to factor, but I'm starting off with the easy ones. By the way, let me go ahead and show you guys the difference between easy and hard, okay? When we talk about an easy trinomial, we're looking at a trinomial of the form x squared plus bx plus c, where the leading coefficient, the number in front of x squared, is equivalent to 1, okay? But when you're looking at a hard trinomial, the leading coefficient is no longer 1. You will have a different value than 1 as the leading coefficient. So it's in the form of ax squared plus bx plus c. So right now, I want to spend the time factoring the easy trinomials, okay? So let me go ahead and give you some steps for factoring the easy trinomials. And guys, listen, it's just like what it sounds. It's easy. So the easy trinomials are in the form of x squared plus bx plus c. So step 1, you want to set up a set of parentheses. Set up 2 parentheses. Set up 2 parentheses, something like this, okay? And in step 2, you want to factor. Remember, when we're factoring these trinomials, guys, it's a combination of the factors from the first term and factors of the last term that must combine together to give you the middle term right there, okay? So you want to factor x squared into x times x and place an x in each parentheses, an x in each parentheses. So in the case of a problem like this, because it's an easy trinomial, it's always going to have x squared, you can essentially say each one of your problems, your factored forms, are going to be in the form of x plus or minus something and an x plus or minus something, okay? Now, step 3, guys, you want to go ahead and find 2 factors whose sum, remember sum means addition, 2 factors whose product, let's do the product first. I said sum, we'll do the sum second, whose product is C and whose sum is B, okay? Find 2 factors such that their product is C and the sum is B. As in, guys, let me put it in layman's term for you. You want two numbers that multiply to give you C, and then when you add them together, you get B. That's all. And whatever those two numbers are, you want to go ahead and place a factor in each parentheses. Now, I'm going to go, oops, let's go back. I'm going to go to the next screen. Here's a little chart that might help some of you out to help you organize this, guys. Okay, let's look. This is going to represent the C factor, the C term, the B term, and then the factors. So you want to look at your C value, your constant term. If the constant is positive and the B value is also positive, that means that you're going to have two positive factors. It works, guys, it works. Now, if C is positive and B is negative, then that means you're going to have two negative factors. Because when you multiply a negative times a negative, you get a positive. And when you add them together, what do you get? You get a negative. Remember, this is the part for the multiplication, the product. And this is the part right here for the sum, the addition. They multiply to give you C and add to give you B. And then, guys, the third option, the third case, is where C is negative. Now, if C is negative, automatically you're going to have a positive and a negative factor. How do you know which one's negative, which one's positive? Larger factor gets the middle sign. The middle sign takes on the sign of the B value. Whatever that B value is, whatever its sign is, the larger factor from C will take on that sign. Yep. All right, guys. So now, larger factor gets the sign of the middle term. I think we're ready to go ahead and do some examples. I am going to go through a series of examples and then I'll be done. Okay, so we're going to start off with something very easy. X squared plus 9x plus 18. Now, if you go back to that little chart, you will notice that C is positive, B is positive. That means that you're automatically going to have two positive factors and the X's are automatically in here. So now your job is to decipher what two factors of 18 adds up to give you 9. What two numbers multiply to give you 18 but add up to give you 9? Think about it. You have 9 and times 2. 9 times 2 is 18, but 9 plus 2 does not give you 9. Then you have 6 times 3. 6 times 3 is 18, and 6 plus 3 is 9. So those are the ones that work. Now, guys, because this one right here, both factors are positive, it really doesn't matter, okay, in which parentheses you put the 3 or the 9. Okay, so that one was easy. Like I said, they're called easy factoring for a reason, guys. Okay, here's another one. X squared minus 12x plus 32. Now on this one, this is an x squared right here. Set up your two parentheses. Again, put in your x's, guys. Include your x's in there. So now the question is this: what two factors of 32? By the way, 32 is positive, C is positive, and B is negative. That means that you're going to have two negative factors. So now ask the question: what two numbers multiply to give me 32, but add to give me 12? And notice I didn't say anything about the negative. You can, you don't have to. You could say it this way: what are two factors of 32 whose sum is negative 12? What are two factors of 32 whose sum is negative 12? So think about numbers that multiply to give you 32. We got 16 and 2, but when you add them together, that won't give you 12. We got 4 and 8. When you add them together, does that give you 12? Actually, it does. Okay? So guys, there's your answer, okay? So does it matter which parenthesis gets the H, which one gets the 4? It doesn't matter because the signs are the same. All right, third example, guys. Now, let's make it a little bit more challenging, okay? I think I'm only going to do 4 examples. So here it is, guys. X squared plus 10x minus 24. So on this one right here, listen, again, split up x squared into x times x. Now you notice the C value is negative. It's a negative 24. So that means you're going to have one positive factor, one negative factor. Now you need to be careful with this, okay, guys? So you want to find two numbers that multiply to give you negative 24 right there. And when you add them together, you get positive 10. Another way to say this, and for most of my students, it's easier to say this. Two numbers that multiply to give me 24, and when I subtract them, I get 10, okay? Two numbers that multiply to give me 24, when I subtract, I get 10. That's easier, okay? So think about it, guys. For 24, 4 times 6, that's 24. But when we do 6 minus 4, 4 minus 6, that's not going to give us 10. So that won't work, okay? 12 times 2. 12 times 2 is 24. When we subtract them, do we get 10? Ooh, I think we do. 12 times 2 is 24. 12 minus 2 does give you 10. Now, here's where you need to be careful. Where does the 12 go? Where does the 2 go? Remember, guys, the larger value, in this case 12, gets the sign of the middle term right there. The sign of the middle term is positive, so that means that the 12, since it's larger, will be positive, and that makes the 2 a negative. Let's do it again, guys, because that was a little confusing, okay? Here's another example. X squared minus 9x minus 36. Okay, set up your two parentheses, split up x squared into x times x. Because if 36 is a negative, you're going to have one negative factor, one positive factor. Once again, guys, think of factors of 36, okay, negative 36, such that when you multiply them together, you get negative 36, but when you add them together, you get negative 9. What are two factors of negative 36 whose sum is negative 9? Two factors of negative 36 whose sum is negative 9. So another way to say this, just like with the previous problem, what are two numbers that multiply to give you 36? Subtract to give you 9. Two numbers that multiply to give you 36, but subtract to give you 9. So let's write out the list. 18 times 2, that's 36, but when you subtract them, we don't get 9. 6 times 6, yeah, but when you subtract them, you get 0. 12 times 3, when you subtract them, you do get 9. So those are the factors that will work. Now, you got to be strategic about where the factors go. So in the case of this one right here, guys, the middle term is negative. The 12 is the larger factor. So this means that the 12 will be a negative while the 3 will be a positive. So there's your factors, guys. Hopefully, that wasn't too challenging for you. And so I am going to stop here. I feel like I should do a challenge question, okay? A challenge problem. Let me just do this last problem. I don't know how long I've been in this video, but let me do this last problem. I try not to go over 30 minutes, guys, because I know how the attention span is. And so it's technology. If you need to increase the speed of the video, by all means do that. You know, 1.25 speed, 1.5 speed, yeah, whatever works for you, okay? So here's a challenge question, guys. When you're factoring, listen, one of the first rules of factoring is this. First question you must ask yourself whenever you're factoring, if you're presented with a problem to factor sugar plums, listen, just ask the question automatically. Does this polynomial have a GCF? In other words, always be on the lookout for a GCF. That is step number 1. Step numero uno, okay? Does the problem have a GCF? And yes, this one happens to have a GCF. So which means the first thing we need to do is factor out that GCF. What is the GCF? Look at all three terms. What are all three terms divisible by? 3. So we're going to divide each term by 3, guys. And what do we have left over? X squared minus 6x plus 8. All right. Now, you don't stop there, because most of these problems, when you get them, they will ask you to factor them completely. So the next step is to go inside the parentheses. See if what's inside the parentheses is factorable. So you ask this pertinent question. The pertinent question is, can I find two numbers that will multiply to give me 8, and when I add them together, I get negative 6? Can I find two factors of 8 whose sum is negative 6? And yes, that is possible. So that means that we can factor that trinomial inside the parentheses into two binomials. And of course, just like we did with the previous problems, we split up x squared into x times x. Because 8 is positive and the middle term is negative, that means both factors are going to be a negative. So the two numbers that multiply to give you 8, but add to give you 6 would be positive 4, negative 4, negative 2. Because negative 4 times negative 2 is positive 8, while negative 2 plus negative 4 gives you a negative 6. I needed to do that one challenging question right there, guys. I believe this is sufficient to help you get through the assignment, so you should be okay. But there is a second part to the factoring, guys. We're not completely done factoring yet, because we got to do the hard trinomials. We got to do the special cases, like the differences of squares and so forth and so on, okay? So that's it for now. Until next time, everybody. Bye.